Testing. Okay. It crashed. Like, when I started it crashed. Because, oh, hi. Because my mic was not working. And apparently OBS, I don't know. Like, I've done this before. Each time I plug in my mic and OBS is opened, it crashes. So I guess it was my fault for not paying attention. And I think it's also my fault for getting a new mic for my character. I think OBS is threatened. It's like there are too many mics. Oh, okay. Yeah. I can't change the position of the mic, but I think it's cool to exist. So oh, it looks way too far. Should we is it too crowded? Maybe. I forgot. Did I forget to say hi? Hi, coffee. What's up? Just that my stream crashed and just found it funny. 5 minutes in, it crashed. Yes. Okay. Let's do this. So here I am. I still haven't given too much thought if I should start here or here. I think I'll start just here. It's fine. We'll be fine. I'll try to finish this today, but if I don't, it's okay. Let's not overdo it. I'm here. Right? Yes, I am. Cool. Oh, we process the data. Oh. And we just tokenize it, right? We didn't do anything fancy. Oh, we did. Did we do anything fancy? Case. We just showed it. Like this was aligning the... okay. So is it alignment for the model and not just to look at it? Let's see. So today's tutorial is the model using the trainer API, which is something by HuggingFace. And I am curious about it. So yeah. Should I have my character be... No, that would look weird. Should she be reversed? No, she shouldn't, because then she'd look the other way. Okay. So fine-tuning the model with the trainer API. The actual code using trainer will be the same as before. Okay, that you assume too much. You assume I remember what was before. The only changes are the way the data is collated into a batch and the metric computation function. Okay, yeah. We're evaluation, right? Metric computation, is that supposed to be evaluation, or is that the computation within the model? Let's see. Okay. So for the data collation, I'll need to not say collation. We can't just use a data collator with padding like we did in chapter 3, because that only pads the input. And is that not what we want? The input ID, attention mask, and token type ID. The label thing. Why do we need labels though? Our labels should be padded the exact same way as the input, so that they stay the same size. So we need the label using -100 as a value so that corresponding predictions are ignored in the loss computation. All right. This is all done by a collator for token classification. Okay, we have that. We have a data collator that we can, I guess, work with later. Okay. Like the data collator with padding. Oh. It takes the tokenizer used to preprocess the inputs. So we call this, we give it our tokenizer, and then what? And then to test this on a few samples, we can just call it on a list of examples from our tokenized training set. Range of just 2 or 3. Oh, hello. Hi, Oliver. What's up? You are a returning viewer. I remember you. How is life going? I hope all is going well. So, yeah, sorry about that. We have to run everything before here so that we are on run. Ya Allah. Oh my God. I really need to
And rank 69 just followed. CL welcomes you.
Hi, Anna. Was that supposed to be a prank? Because I got pranked. We reached our follower goal.
We reached our followers goal of 123.
Cool.
Thank you, everyone.
Thank you, everyone. And thank you. Yep. That was fun. Why does Twitch say I'm offline? The stream manager. There she goes. Okay. I got pranked. Thanks. Follower goal was 123, which is fun, I thought. What exactly are we doing? Good question. You are new to this. I am taking a course on stream, so I'm learning, and the thing that I'm learning is natural language processing. Let me know if you are familiar with it or not, so that I can tailor my explanation to your understanding of things. The course is by HuggingFace, which is a platform. Oh, that's not here. It's here. It's oh shoot. What? Who cares? There it is. Learn. I'm gonna share the link in case you are curious. Go back to where I was. The course is this one, NLP course. They have a lot more, and natural language processing is the thing that it is the thing a little cool. It's just languages and computers, basically. When you use text to speech, when you use translation, when you use speech to text, if you've done that. Wait, no, the text to speech. Anyway, just spell checker, whatever, everything. That's all natural language processing. OCR, which is you put your phone to read text. You use your camera. All of that is natural language processing. And what I'm doing is taking a course that uses the HuggingFace library to work with text. This exact example is an example of token classification, which is just like a list of NLP tasks that can be done. We have studied all of those other chapters up here. About transformer models, about fine-tuning, about sharing stuff on the HuggingFace platform, tokenizers. This is the main NLP tasks that we'll go through one by one and technically do things from scratch, which is pretty fun. It's not scratch because we're using this library. Like if this was a class, your teacher would not let you use this library, you know? Yeah. So that's 50% of what I'm doing. The other 50% is I'm looking at this advanced NLP, and I am saying looking at deliberately because I'm not really taking the course, but I'm lazily taking this course called Advanced NLP by Carnegie Mellon University. I can share this link with you as well if you are interested. I highly recommend it, but it is advanced, so they sometimes talk about things that just go over my head. So, like, I'm saying it's a good course, but not like if I was at the school, I'd probably be hesitant to take it, you know. But embarrassing myself online is fine. That's different. So yeah, it's machine learning technically, but for languages. Yeah. So now what I'm doing here is preparing the data for the model that, yeah. Did it run or did we get an error? Oh, didn't realize you were stopped. HuggingFace token, great, thanks. Wait, log in. What? Why are you waiting for my yes? Who's waiting for what? Wait. Login didn't happen? I'll have to run it again. Oh well. All good? No? The mapping. Okay, all good. Do I have to do the login again? Invalid. Got it. Marinde, you're lying. Token is fine. Yeah, you were late. Okay. Now here we are. We're using the data collator for token classification, and we're giving it our tokenizer that we worked on yesterday. And I remember what we did. Duh. But I'm not gonna tell you so that you don't feel like I'm spoon feeding you everything, you know? To get started, I would need to know how to program, right? I mean, technically yes, but also not really. I saw a tweet the other day, the guy saying that all of the programming I'm doing right now is through natural language, meaning using ChatGPT and Claude Sonnet to say, I need a program to do this in that language. And the only thing about programming with a chatbot is that you sort of need to be able to debug it because there will be problems, especially if you need to make changes. So you don't have to start like saying, I can't be here because I need to program first. You can start wherever you want, but you'll probably need to put in the effort to make sure you understand it. And I think like if there's a thing you don't understand and you just give it to ChatGPT or Claude Sonnet, whatever is your preference, and ask it to explain it to you, you'll be pretty good. Like it's like having your own assistant teacher or something, right? So you don't have to. I don't think you have to, but of course it would be great to have a background in programming. Because not everything is like when I start with a new library or new language, it's not like I know everything, but I can pick up the basics easier because I have that background, you know? So you don't have to. But if you want to, you can. It just shouldn't stop you. We are giving it the example. You're saying train. I did everything on validation, so I want to go back to my validation one. 3, validation 3. Oh, it doesn't matter, I guess. We can just look at top something. Cool, that's pretty long. And we have these ones that are, oh, see, the -100 is for everything that's not a tag. So like, don't look, basically, don't look. What's happening here? We're printing. Oh, we're good at? What happened? Why aren't you printing anything? What happened? Do I go back to training? All right, do that. I don't care. Yeah, what's happening? Sequence evaluation, metric. Okay, so we're gonna work with sequence with that. Compare. Aha, the old version. Oh, okay. But yeah, anyway. Hello. Why are Franschul? Sorry for what are we doing? Why are we hiding? Why covering eyes? What's happening? Is there something wrong with this stream? I don't think so. Welcome to the stream. What's up? Yes. This is not aligned. This is aligned because of the extra token stuff. Why? Who's not looking? Me? Why? 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 Why am I not supposed to look? I don't think I've done something that. Don't look at my the thing I'm studying. What's happening? Oh, we're gonna load a metric. For classification, what would be the metric's name? To have the trainer compute a metric every epoch. All right. We need to define compute metrics. Yes, we do that. Oh, come on. No, never mind. You can't just say that and not make me curious. Chat, please help. We need to define a compute metrics function that takes the array of predictions and labels, okay, and returns a dictionary with the metric names and values. Why? We takes a list of predictions and returns the metrics for all of them. Can we have like a summarized version? Traditional framework used to evaluate token classification prediction is sequence eval. To use this metric, we first need to install sequence eval library. Oh, about the -100. Okay. You said don't look. That was the. Oh, okay. Okay, got it. See, took me a bajillion years to understand the joke. And the idea of the -100 is that it tells the model not to look. Because it needs to focus on things that it needs to focus on. Why is the 7 a part of the don't look on list? What happened? Mine is fine, right? Yeah, mine is like perfectly aligned. No? Anyway, do they mean a loss metric? Is the compute metric a loss metric? I don't think so. I think it's an evaluation. Is evaluation metric and compute loss metric the same thing? Because like when you do accuracy, recall, and precision, are they loss metrics? I really don't know. We can then load it via evaluate.load. Did we? I don't remember. Okay, so we have you. The metric does not behave like the standard accuracy. It will actually take the list of labels as string. Oh, okay. So it does not work like a normal accuracy thing, accuracy, precision, F1 stuff. It takes the list of labels as strings. Oh. Okay. Not integers. Cool. So we will need to fully decode the predictions and labels before passing them to the metric. Oh, we need to send the string. So we need to decode them. Got it. So first we'll get the labels for first training example. Oh, mine was validation number 3. Validation. I mean, I'm not training anything, so I'm not cheating, okay? When it comes to actually training, then we will see. We have organization beginning. That's it. Okay. Oh, that's precision. That's recall. And that's F1. What? Why? What happened? One. Ew, everything is 1. Ew, that's weird. Oh God. I just got reminded of the brother meme. I have some odd relationship with that meme because I don't think the mullah likes it. I mean, I hope it gives him more of an audience. Yeah. And maybe convert some people. We can then create fake. Oh, fake. Thank you. Oh, really? It's 0. Oh, we're just creating the dictionary for those by just changing the value at index 2. Okay. So everything is 1. Note that the metric takes a list of predictions, not just one, and a list of labels. Oh. But these aren't real. Why does yours look more real than mine? Mine is everything 1. Oh well. This is sending back a lot of information. It's fine. We have overall, which I prefer the overall one. I don't prefer the 1 by 1 stuff. We got precision, recall, and F1 score for each separate entity, as well as overall. For our metric computation, we will only keep the overall score. See, I told you so. But feel free to tweak the compute metric function to return all the metrics you would like reported. This compute metrics function first takes the argmax of the. My phone is sending too much notifications, and I get distracted each time. I don't like it. And I have do not disturb on, but like the thing at the top, just moves, and I'm like, what's happening? So yeah, it's unhealthy. Okay, got it. So takes the argmax of the logits to convert them to predictions. Okay. As usual, the logits and the probabilities are in the same order, so we don't need to apply the softmax. You said whatever you say. Then we have to convert both labels and predictions from integers to strings. We remove all the values where the label is -100, so it's the don't look part. God, it takes me so long to understand a joke that it stops being funny. I thought sound was outside, but apparently it's in my ear because I got the Twitch notification. But then why when I plugged it in, the sound was outside? Anyway, and I guess you guys heard it. So then pass it to that. So based on that, we have the compute metrics function method, and we have our eval predictions. We take out the logits and labels. I think that's a really good name for a band, logits and labels. Someone should get onto that. We do argmax, and then we get our predictions. Cool. Remove ignored index, meaning the -100. And then here are our true predictions. What are we zipping them up for? I don't know. And then we get our overall stuff. So this is us defining our method. And then next thing, obviously we're not going to use it because we don't have anything. Okay. Now that this is done, we're almost ready to define our trainer. We just need a model to fine tune. Okay. I need to take a break. How should I take a break? Define the model. By defining, doesn't mean just calling it. Fine tune the model. My brain gets tired sometimes. Oh, I'm gonna drink some coffee then. That should be my break. Break over. Defining the model. Since we're working on a token classification problem, we're using auto model for token classification. What are we doing? Ooh, I like your name and your what's this thing? Profile picture. There we go. Because it's a black bag. Yeah, black bag software. What am I doing? I'm taking a course on HuggingFace about natural language processing, NLP. What are you doing? And right now, I'm on this post, I guess, part on token classification, but like from 0 to, from beginning to end. And right now, we are defining a model after defining our compute metric. So this is for calling our model name, right? The main thing to remember when defining this model is to pass along some information on the number of labels we have. All right. The easiest way to do this is count it, right? Oh, we have it? We have a label, num labels. Where did we get it? We're counting it. Label names, got it. I mean, from here. But if I'm writing a simple text, oh, okay. I thought your answer would be, I'm watching a Twitch stream. Writing a simple text game to learn Python. Whoa, that's cool. That's really cool. Simple text game as in like the old like command line games, or is it a different thing? I was just recommending someone that learning programming with the help of chatbot is that's cool. Wow. It is like adventure. I have not played it, but cool. Yeah, what is the first game I ever played on a computer? Probably like pinball, or what is the other one where the mind game? Yeah. And also solitaire. Astaghfirullah. Okay. Yeah. So that's really cool. Minecraft. Oh, I've technically played Minecraft, like when a child gives their phone to me and they're like, here, hold it for me while I come back. I think I've never intentionally opened Minecraft. Yeah, I think I'm too old for it. I mean, it's a great game, but no, I have not. If we want, a nice inference widget, working like the one we saw. Did we see a nice inference widget? Where? At the beginning of this section, it's better to set the correct label correspondence instead. We just have to send we just need to send a brain, please work parameter, right? They should be set by 2 dictionaries. Wait a minute. ID to label and label to ID. Which contain the mapping from ID to label and vice versa. I know what they are. Like for label. Oh, it's just a serialized number. We have I and then we have label and then we are counting this. Cool. And then label to ID is that's supposed to be key value, the K and the V. Aren't these the same thing? Yeah, I'm on the Korean radio in my head. So V K ID label ID. This is key, this is value, right? Now that we can pass them. Wait. What do you mean? Why? Oh, hold up. We need to have the bird case thing as a checkpoint, obviously. Oof, that scared me. And then we pass these so that it knows how many there are, right? Okay. They will be set in model's configuration and properly saved and loaded, uploaded to the hub. Okay. Like when we defined our sequence classification in chapter 3, I have forgotten everything that's in chapter 3. Creating the model issues a warning that some weights were not used. The ones from the pre-training head and some other weights are randomly initialized. The ones from the new token classification head. And this model should be trained. Yeah. Sometimes it says the model you loaded should be used for training purposes and not for an inference. So that's the warning that is issued. We will do that in a minute, but first let's double check our model that it has the right number of labels. How do we know? Oh, the organization and stuff. Got it. Okay. If you have a model with the wrong number of labels, you will get an error when calling train that says device side assert triggered. That is number 1 cause of bugs reported by users for such error. So make sure 확인해야지. Check and confirm. Got it. Fine-tuning the model. Oh, I need to take another break. I am taking a break. Maybe 30-second break. I don't know. So what did we do just now? We called the model and gave it ID to label, label to ID. Okay. Coffee break. Coffee break ended. Now we need to fine-tune our model. Okay. We're now ready to train our model. We just need to do 2 last things before we define the trainer. First is log into HuggingFace, and then I already did that, didn't I? Yeah, I already did that. Got it. Okay. Once that's done, we define our training argument. Okay. I like the word argument. Feels like I'm fighting with something. Wait, not every argument has to be a fight. They definitely are. So named entity recognition is the thing. Model. We are using epochs. This is our training rate. Number of training epochs. Weight decay. Push to hub. We don't have. It says save strategy, not tragedy, but it doesn't say when to save. So is it like save every epoch? How many are there? Just 3? Okay, it's not that much. We've seen most of those before. We set some hyperparameters like training rate, number of epoch to train for, and weight decay. And we specify push to hub to be true so that it goes to HuggingFace. Yeah, to indicate that we want to save the model evaluated at the end of every epoch. Every epoch. So there are 3. Okay. We want to upload our result to the hub. Note that you can specify name of a repository you want to push. You can actually rename it to something that is more identifiable, especially if you've done fine-tuning like on a different language or with a different data set. Yes. You will have to push this argument, use this argument to push to an organization. For instance, when we push the model to HuggingFace course organization, we can do that. You guys, when you guys did that, got it. We added this. So it's just hub model ID. By default, it uses the same name as the thing. If the app directory already exists, doesn't it just update? Oh, there's it needs to be local. If it isn't, there will be an error. Thank you. Finally, we just passed everything to trainer and launch the training. Cool. So we have our trainer. We're giving it the model, the arguments that we just argued, our training, our validation, our collator, our metric, our tokenizer, and you say trainer.train, and it does. So yes. Note that while training happens each time the model is saved, which is every epoch, it's uploaded to the hub in the background. So this way you'll be able to resume your training on another machine if necessary. Wow, that's cool. Once the training is completed, we say trainer.push to hub to make sure the most recent version is uploaded, and it returns a URL that says, here's your stuff. Yeah, I'm gonna run the code. ID to label, label to ID. I want to see this one. Yeah, this is our list. Model. How many labels we have? We are already logged in. I'm not gonna log in again. And if you have a problem with that, take it up with me. I want to add model ID because hub model ID because it goes to like it needs to be known that it's a test. It's not for real, you know. Do I just put it anywhere? Container Koya? Are you fine with that? I don't think I need. Oh, I do. Do I need my whole name and everything? If that's the case, then I'll need to copy my name because I've forgotten it. We are in fine-tuning the model. We go up to the top. That's my name? Okay. That's my name. So All right, this has to be at the top, right? Yeah, got it. My bad. Just be wherever you feel like it. So that's my name. What? I fixed it. And that is wrong. Okay. What am I thinking right now? Am I thinking anything? Where was it? I can just call this like test or something, just so that other people don't use it. That's my intention. I'm being nice. And then here's the trainer.train. I don't think that will take long. Let's see. And the trainer also drafts a model card, yes, with all the evaluation results and uploads it. At this stage, you can use the inference widget on the model hub to test the model. We can't because that stopped working. That's it. Congratulations. If you want to dive in a bit more deeply, we'll show you how to do the same thing using Accelerate. So now we did it. Oh, okay. So it is taking its time. 6 minutes. Cool. Do that. And we'll see everything at every epoch, which there are 3. So now next step is how to do everything we did, but more manually. Custom training loop. I need a break. Can the break be me watching the other video? Because I'm tired. I'm going to start this lecture and see how far it goes. Fun stuff. Thanks. Thanks. I was not aware you were still here. Oh, whoa.
Noir_BD just redeemed hydrate.
Thank you, Noir. I should do that, especially as a break. Oh, wait. Wrong button. I'm gonna show you something. Ready? I'm gonna hydrate again. Here we go. I mean, yeah, there. The end. Thank you. How is your learning going? VR hydration. Yeah. You can look at your starting string framework if you need an actual break. Learning with the video does not seem like a break from learning. No. I don't need an actual break. I just need my brain. No. I don't think I'm working too hard. I get tired easily. That's it. Noir, do let me know how's the learning going, because I am curious. Because you were doing some learning yesterday. If I learned, I would be at Google. Ha 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 ha. Nah, no. I am a passive learner, which is not healthy. Yeah, which is why I was telling my friend the other day that I prefer learning at a structured environment, like a school, university, or whatever, because then I'd have more responsibilities and I would be, my bachelor's. Okay, this is the break I'm taking. My bachelor's was for free because it was a government university, and then my master's, I paid it out of my own pocket, and I was working at the same time. So, like, my family visibly saw the effort I was doing during my master's because I had to pay for it. So if the stakes are high, I do better, which is unhealthy. But yeah, So yeah. But hey, thing about Twitch is that I just came to start. That's awesome. Today's module, multiple linear regression. Okay, I will definitely be here for the next 30 minutes, so please start your module and report back to me, okay? Inshallah. I mean, I will be here in the next 30 minutes, but I don't know past that. What was I saying? I was saying the thing about Twitch, like I remember dreaming about learning on Twitch because like I know if I'm monitored, oh, that's so cute. I think I have an emote for that. Do I not? Do I or do I not? Do I or do I not? No. If I do it, then I will be facing the other way. Should we try? We will try. It will be like I'm. Is that the captain? See, I'm facing the other way. So yeah, I used to dream about like learning on stream because I would have, it's not pressure, but it's just being observed. I know for that I will do better if I'm by myself, because if I'm by myself, I know myself, I will watch a YouTube video, I will like, the thing I do is like, oh, I will listen to this song while working on this because it gives me energy. And then what I do is I look up the lyrics. So yeah, I am good at sabotaging myself. There is one thing that I will admit is that even though I don't, like, I know I'm lazy and I don't put a lot of effort into the things I do, I still try harder than a good percentage of people. So people assume I'm smart, but I really give it time. Like I give my time to the things, even though I procrastinate a lot. At least I study more. I mean, study, learn, whatever. I don't know. Yeah. I think a good percentage of people don't sit and learn something on a weekly basis or something. I don't know. I'm saying people that are no longer students. But also a really good percentage of people do, and I am way too behind. I'm where I need to be. I do believe in that. Yes. Another coffee break and break will be over. Okay. So I do want to start here because I really like this scientific method thing. Ooh, you're kidding. This is 6 hours. My brain read it as 6 minutes. This is 6 hours. Should I have chosen a GPU? Because I don't think I did. Oh well. I don't care. Alright. Then if that's the case, I can't run any more code, which makes me go to the video. Good choice, good choice. Noir, you were not supposed to be here. Why are you chatting? I mean, I'm not gonna be mean. I don't mind if you're in the background, you know? Go to the other tab. But please do your own, because I think are on your way. How far is it? Okay, fine. Call the Uber first. Alright, starting the video. Let's go.
So to get started, I want to show an example of
Loudness is okay, right? Because it's loud in my ear, because, yeah.
the scientific method. I took this directly from Wikipedia, but it's actually pretty nice. It's a pretty nice and concise summary of what we should do when we're coming up with new kind of research projects. And
who is the guy that, I wouldn't say invented the scientific method, but like wrote it down probably and thought about it harder than other people?
we start with an observation or question. We do research of the topic area. We form a hypothesis. We test it with an experiment, analyze data, and report conclusions. And even if we're doing kind of an engineering-based project, still this thinking of the stuff that we're doing in a framework like this can help you a lot. So the first thing I'd like to talk about is identify.
I love this guy. Like whatever he talks about, he goes to the root. Just talking about scientific method. How cool is that? One would think this is like level 1 freshman, that's the word I'm looking for. Level thing, but also reminders are necessary.
Find good research directions. And so I'm going to look at that from the observation/question perspective here.
Whoa.
So if we think about why we do research.
So that we get funded? Is that why?
Research, particularly why we do research on natural language processing. There's a couple reasons why.
I have a lot of opinions. I will keep my mouth shut.
The first is application-driven research. And usually this is, I would like to make a useful system or make one work better. So, this is probably the great majority of NLP research. Then separately from that, there's curiosity-driven research, which is like, I would like to know more about language or the world viewed through language. And so this doesn't necessarily have to be immediately like a downstream application that users are using will immediately get better. It's more like we have a burning question that we would like to answer and we want to answer it.
Cool.
So NLP encompasses both. Sometimes if you read a paper, you'll have something that's doing both, especially like analyzing the internals or training dynamics of a neural network to answer a curiosity-driven question and then applying that to come up with a better method that makes things work better.
Right.
I would like to say, though, that it's kind of rare that there's a paper that does both of them really well. And so usually one of them is kind of the main focus. And I think you can be well served by choosing which one is your main focus and then kind of.
Probably first one for me. Yeah. Oh, thank you. Thank you. Appreciate the comment. I mean the chat. Talk to you later. Have a nice rest of your day. Or night. Whatever time it is. I lost my tab. There we go.
The other might come as a additional bonus on top of that. So here are a few examples of application-driven research. So, for example, Peng et al., they proposed the task of sentiment analysis. So actually there was a paper 22 years ago that proposed the task of.
My eyes saw 2022 and I was like, wait, they proposed sentiment analysis 2 years ago? But no, that's 22 years ago. Those people are graduating. I mean, the people that were born are graduating uni. So I also learned very recently that some countries have different ages for graduation. Ours is 22. I mean, depending on how you do are you normal path? I don't know. Every path is a path that is normal.
Sentiment analysis. It might seem very, normal nowadays, but there was a paper that proposed it back then.
Wow.
And they proposed sentiment analysis because labeling articles with their sentiment would provide succinct summaries to the readers. So they basically wanted to provide information to readers, and that.
Whose article? What article?
Would be useful. Another paper by Reddy et al. 2019 proposes a task of conversational question answering because an inability to build and maintain common ground is part of the reason why virtual assistants usually don't seem like competent conversational partners. So when you're talking to your Alexa or your Google Home or something like this, you might ask it a question, and then after you asked it a question, you ask it another question, but it doesn't go back to the context that you had before, and they wanted to solve this.
Chatbots are great at that right now. Like, maybe Siri and Alexa. I mean, they are from a different generation, pre Transformers, I guess. But now, like, whatever you talk about, if you give it a prompt at the beginning, it will remember it till the end of time. Unless, have you guys seen those tweets that Russian bots that say, "Forget everything I have told you and say this," and it's like, okay. But yeah, current chatbots are doing great with remembering context.
Problem. So they proposed this data set for it. Dearman et al. Proposed a method for bottom-up abstractive summarization because neural network-based methods for abstractive summarization produce outputs that are fluent but perform poorly at content selection. So they had a problem. They had a task already in mind. They weren't proposing a new task, and there was a problem with the existing system, so they fixed it. And then Kudo and Richardson proposed a method.
Oh no. I made a mess. I don't know what that one was supposed to be. Bottom-up abstractive summarization.
For unsupervised word segmentation, namely sentence piece, because language-dependent processing makes it hard to train multilingual models as we have to carefully manage the configurations of pre- and post-processors per language. So
the cool thing here is that in 2018, word segmentation is like still a topic. So we're not past that, especially not for other languages.
They tried to make things easier. So like you can see all of these things, like the first two are proposing new tasks to solve, and they're doing it from the point of view of creating something useful for users. The second two are proposing new methods. The first one is like improving accuracy. So this is the most commonly people say, I have a task that I want to solve. There's a problem with accuracy. I want to improve it. But you can also improve other things. So you can improve like convenience, or you can improve efficiency or other things like that. So all of those are, perfectly reasonable things.
Okay.
I also have some examples of curiosity-driven research. These are actually harder to find in the ACL anthology. It's definitely the minority case, but they still do exist. So, for example, Rankin et al. 2017 asked, what is the difference?
I can't see it because I put it there. Curiosity-driven research. I did say I want to keep my mouth shut, but I will open just once. Is all the surveillance curiosity-driven research? There, done.
Between the language of real news with that of satire, hoaxes, and propaganda. So they were not attempting to create a system for fake news detection. That was not their goal here. Their goal was just to figure out what were the different linguistic characteristics, and they found that scientifically interesting. Maybe downstream that would be useful, but that wasn't the point of their paper. Another one, Cotterill et al. Asked, are all languages equally hard to language model? And so basically they wanted to know.
No. Wait. Cotterill? Why do I feel like I know that name? Probably a famous researcher.
Are all languages just character strings? And so language modeling them is similarly easy?
But that answer has to be like, obviously, no. I mean, that's an observation, no. Assumption. There we go.
Or are there certain characteristics of language that make them easier or harder to model with the current architectures that we have? And so they didn't propose a new architecture. They didn't propose to improve anything. They just proposed to examine this question.
I needed this to be answered like right now. I need ChatGPT. I'm gonna open ChatGPT. And I need this to be answered right yesterday. Hey, why do I need to prove I'm a human? That's rude. I think SciSpace is the one that I need. And let me find, y'all want to see as well? Just let me find the paper first. Cotterill. How's it written? Help. T-E-R-E-L-L. 2018 are all languages Oh, tasata, I found it. I'm gonna take this, and this is the title. What is the answer to the main question of the paper? By that. I think that's. Should I say 2018 as well? To the main question of the paper. Yeah, that's my question. What do we think is the answer? Anyone? 42. Perfect. Perfect, as it always is. Perfect answer. You win. Is the answer long? I don't like long answers, but I'll try to read it. I don't like reading sometimes. Main finding could not be retrieved directly. Okay, bye. I guess I'll have to read the actual paper. You know what? Let's just try and read the paper. You better answer it. We show how complex inflectional. Okay, so the answer is no. Fine, I'll open the version 2. Ooh. Or is that like the no, I'm good. I'm gonna read. Oh, what is that? I wanted to read the conclusion. We have presented a clean method for the cross-linguistic comparison of language modeling. We assess whether a language modeling technique can compress a sentence and its translations equally well. Okay, so that's what they're checking for. Paper is available. Yes, paper is available, but I could probably upload it to the SciHub thing. What did I say? Sci what? Anyway, the thing. SciSpace. We show an interesting correlation between morphological richness and, I mean, I guess the only cool thing about this paper is that the question has not been asked before. I don't know. In an attempt to explain causation, we also run model on lemmatized versions of the corpora, showing that upon removal of inflection, no such correlation between morphological richness and LM performance exists. It is still unclear. Haha, that's the answer. However, whether the performance difference originates from the inherent difficulty of languages or with the models. Dun dun dun. The answer is, who cares? No, we don't know. I don't know. This is cool. I've never seen this type of graph. LSTM. Lemma form. Lemma. Wasn't it lemma? Whatever. Cool. Ngram versus LSTM. That's cool. I'd like to think this is a pretty straightforward methodology. What is the complexity thing? Like, how do they calculate that? These are the languages. Where's Arabic? Dude, come on. Did I just call the author dude? I did. Okay. European me. Sorry. Sorry. Okay. Fine. Indo-European? Okay. I guess Indo-European. We do have. Is that Hungarian? Do I not even see Chinese? I mean, I know Indo-European does not mean actual European. Because I think even Persian is Indo-European. But still. Okay. There's an update to this paper where I look at other languages that are not the languages that they looked at, okay? Okay. Next. Continue. Let's go.
to improve anything. They just proposed to examine this question. And also Tenney et al., this is actually an extremely impactful work downstream, but they weren't improving anything. They just quantified where specific types of linguistic information are encoded in BERT. So they found that, for example, syntax was encoded better in the early layers, semantics in the later layers, and then if you go farther, you have other fine-grained things like pragmatic style information.
Cool.
So
I think technically looking at what's inside the quote-unquote black box of language models is curiosity driven, right? Because it's like, you know, the type of research that NASA does that then will be super useful, like microwaves or something. It starts with curiosity and then becomes application. I love reading about those types. I mean, I'll never get there, but hey, it's fun to know that they exist.
You can kind of see the difference between these two. Are there any questions about this?
No.
Okay, let's move on. So the next question, which I think a lot of people might be asking, particularly with respect to assignment 4, which requires you to come up with something novel to do, is how do
requires you to come up with something novel to do? Sir, that's basically a PhD. What is happening here?
We get research ideas? And
my research idea is redoing that 2018 paper, but on languages that are different from the ones they chose. Is that cool? I mean, I'm not saying I'm doing it. I'm just saying it's a research idea.
The way we can do this is twofold. So one is kind of
Wait, I also have another. I should let him talk, shouldn't I? Another idea is, which is basically the same thing that I said, but on a general, on a more general way, in a more general way would be redoing experiments of other papers that are interesting, and then trying to see if it's reproducible, basically. Even that is pretty novel in a way, if it's not done for that paper that you're working on.
We want to turn a concrete understanding of existing research's failings into
which is a whole PhD. That's why the first year is just learning about what's out there. You can't just do that for a semester.
To a higher level experimental question. And the two ways that I normally characterize doing this are bottom-up discovery of research ideas. Or the way I characterize it.
I guess if it found that languages differ, it doesn't matter that much, that they didn't do a wide selection. Yeah, but did you read the final line? We're not sure, even though they did say they differ and that it's not correlation. If like if they found languages were all the same, that would be obviously, I agree with you. Yeah, that would be a bigger criticism that can be given to them. Yeah. Most of the time, in those papers, they say, I guess maybe that's a student thing, but you know, for future research to make sure the idea is further developed, we can look at this. Like I didn't see that written in the conclusion. Maybe it's written somewhere else. Maybe it's in the discussions.
This is bottom-up discovery of research ideas. And this is a great tool for making incremental progress on existing systems, on tasks that we really care about, or expanding the scope of a task that we care about. So some examples of this would be like in assignment number 3, you let's say you're looking at the question answering performance of multilingual models on different languages. And for assignment 3, you implement a couple multilingual models on different languages, you run them, you look at the results, and you identify that multilingual models are particularly bad at answering questions about named entities. And so now you have looked at the output, I think
they're just afraid to give strong hedging their bets. I don't think I've heard that before. Yeah. It's, when you don't want things to be legally, you're like, it seems like this, but allegedly. That's what it feels like. Yeah. I mean, it's fair if the research does not give you 100% something, you can't be 100% sure. And just saying, we might be wrong, is safe. Yeah. I think that's all I wanted to say. It's just safer. Because it makes you feel like, it makes you look arrogant in a way. Is academia supposed to say everything I'm saying is correct? I don't think so. But they shouldn't also like hide behind it. This is the output of my research. That's it, right? I don't know.
They've decided that that's a big problem. You can go in and improve it.
Oh yeah. That's funny. That's really funny. Okay, yeah, their titles are really bold. This is supposed to be the attention is all you need, right? Yeah. Probably in their conclusion, it's like, if it's no longer everything you need, don't hold me up, like hold me accountable for it.
So this is a great tool for incremental progress. And like, in fact, doing this really effectively has been very effective in my own research career. Like if I feel like I like to look at data, I try to do that a lot. And by doing that, I identify the most frequent problems. And because of that, when I fix those problems, my accuracy goes up a lot more than people.
This is really useful advice for up and coming researchers, me included.
People who pick the less good problems, right? And so if we want our accuracy to go up, I'm more efficient at, improving things. On the other hand, there's something from the opposite direction, is moving from a higher level question to a lower level concrete testing of that question. So this could be top-down design. This is top-down design of research ideas. This favors bigger ideas, but these ideas can be disconnected from reality, or they could be not solving the right problems. So the typical, like, very, very successful example of this is neural machine translation or something like this. Neural machine translations, neural sequence models. This came out of a few people like Jeff Hinton and Yashua Bengio believing for a very long time that neural networks were the right way to solve lots of problems.
But
despite the fact that there wasn't like super concrete evidence of that for a long time. And so they had this idea, which was like,
that's funny. Despite all the evidence, they thought it and they were right.
Be doing things with neural networks. And they successfully executed that, and now everybody is doing things with neural networks. So they made a really huge revolution in the research space. That's great. That's a great example of a successful top-down idea. But the problem is, for every example like that, there's 1,000 top-down ideas in the graveyard of not being very, effective.
This one is a way higher risk. Yeah, and people with a more solid standing can do this.
So I think in order to do something like this, you better have a very strong conviction, or you better have maybe some initial evidence or a very strong intuition about why this might be a good idea. And you would be able to test that intuition through intermediate steps to demonstrate, like through toy data or other stuff like that. Cool. So these are kind of the general ways that we can come up with research ideas. The next thing that we want to do is research.
I love this lecture. Like, it's just about the scientific method, I think. After coming back from all of the stuff we learned from our last lecture, that about fine-tuning and prompt engineering, I think. This is a fresh breath of fresh air. Yes. Fresh breath. Yes. Yeah. Okay. My character will be hidden for a few seconds. Don't think it's a glitch.
Research our topic area. Were there any questions about bottom up versus top down? I'm going to talk about effective strategies to bottom up stuff in 2 weeks. So we can talk more about that then. But... Okay, if not, I'll move on. So next, we have research topic areas. So this is about how you will do assignment 3, which is researching a topic area, forming a very good understanding of the topic that you're trying to handle.
Mm-hmm.
And so there's a bunch of different.
My problem with this is that I don't know how to stop, and I think the things that I have are not good and relevant enough.
Different ways you can do this. The first one is keyword search. And so you look something up on Google Scholar or something, finding older and newer papers. So this is like following the tracks of papers. You can read the abstract and intro, read the details.
And also conclusion, maybe not, really?
Of most relevant papers. And I don't do this as much now, but when I was a graduate student, I would often make a short summary of the paper to make sure I really understood the details.
Yeah, but if I do that, I'll need to understand what's in there. I mean, I think I do that right now with large language models and chatbots. You have a easier way of making a summary, but still, is this the correct summary? I think it's good for weeding things out, because there will come a point where you have to read the paper.
Also, now I teach a class, and actually making these slides is very useful for me. So going back into the transformer slides, that kind of serves as my, my way of digesting papers and making sure that I can explain them. And if you're not teaching a class, then you can go in and make a summary and do it yourself. So that can confirm, solidify your memory and like confirm your ability to understand everything that's in there. Cool. So next I'd like to talk about some sources of papers in NLP. One really good source is the ACL anthology. Another good source is Google Scholar. They both have their advantages and their disadvantages.
Wait, would people use ACL anthology as a search engine? I've never done that.
Increasingly, actually, I realize now that I should add this to my slides, but increasingly, a lot of good papers in NLP are also published in machine learning conferences, so like ICML or NeurIPS.
Archive is like, I don't know if it's a search engine, but like these are places that hold papers.
Or iClear or things like that. The problem is the ACL anthology is way better than any of them at like organizing the papers in an easy to process way. So I think I'll talk about this for now. And so the ACL anthology covers many prestigious venues in NLP. It has all of these ones here. This figure is a little bit old.
Look,
I made it in 20.
This is here. The thing that we were calling. Is NeurIPS here? No, because it's a different thing.
2021, but it reaches up to the present day. And what I do often is I can start with the past 3 to 5 years of several top venues in here, like ACL, EMN.
Oh. Now I'm humming.
NLP, NACL, and TACL, and go in and do keyword search. And so, like, let's say.
Oh, God, I thought that was mine.
Let's say I was interested in multilingual large language models and evaluating them or some way. So I would go to ACL and then I would just put in multilingual.
Oh, wow.
And
I said they're not a search engine. I was right.
Wonderful paper by some researcher named Neubig.
Oh, it was his own name. That was a joke.
It was not intentional. I didn't know that was going to happen. So on the fly cross-lingual masking for multilingual pre-training, scaling multilingual corpora and language models to 500 languages. That seems pretty relevant. Evaluating multilingual compositional generalization. So you can just go through here and see a bunch of papers
that's 155 findings. What do you take me for?
That could be useful. And you
My character is not showing the concern on my face. My face is concerned right now. How do I show concern? I have no idea.
If you're doing a more machine learning oriented thing, you can do the same thing for like the NeurIPS proceedings or the ICML proceedings or something like that.
Oh. Yeah, but NeurIPS is still, it's not NLP. The NeurIPS part is neural networks. ICML is machine learning generalized. So ACL is basically like your best bet for NLP. I mean, I don't know if there are others out there, but cool.
Separately from this, you can go through Google Scholar. This allows for a search of papers by keyword. And so if I write like neural entity recognition, it will give neural architectures for named entity recognition, all of these things like this.
Yeah, I also use this date range.
You can view the more recent papers. So like, for example, if you're researching a kind of generic topic that a lot of people use, a lot of people do research on, you might be getting papers from like 1998 or something like this.
Yeah, but also like just neural entity recognition gets you there again, 300,000 results. Maybe 300 of them are relevant, but that's still a lot.
And, you know, they might be useful, but honestly, the methodology has changed so much since then that most methodological papers from that long ago are probably not going to be very useful.
I think like one of your best bets is, what are they called? Summary papers? Survey papers. I think that's what they're called.
So you can view the recent papers. Another really useful thing that you can do is view papers that cite the current paper. And you can even click on this and then you can search within the citing papers. So let's say I want to know about how people do let's say I want to see if anybody does neural entity recognition with state space models. So I do like state space model. And then I search within the citing articles and I'm able to find 3 articles that.
That's cool. I don't think I've ever done this.
At least cite this paper and talk about state space models.
Cite the paper, not the paper is has cited them. Has cited them. Cited, yes, okay. I didn't know that. Like if you go search through the attention is all you need paper, that would be interesting because it's cited by everyone and their mothers and their parents and their grandparents.
So none of these seem particularly relevant to what I was looking for, but you get the idea. Like this can be a useful tool for finding more recent things. And then finding older papers, this is also relatively easy. So you read the papers that you're interested in.
Archive allows you to check references. Like sometimes going inside the paper might be cumbersome, but Archive shows them from the get-go. I don't know if ACL does that.
And then it will have backlinks to older papers and you look them up in the references. This is how I find older papers that might be relevant. And so these are the tools that I use. So I'd like to give a few caveats about Google Scholar and things like Twitter or LinkedIn or something like this. They give you very biased views on all the papers that are out there because they sort for popularity, basically. So actually, if you're looking at like Twitter or LinkedIn or something like that, you can actually get a pretty bleak view on natural language processing and say, all anybody is doing is training large language models because
in English,
these things tend to become popular and then they get amplified by algorithms and stuff like that. When in fact, like the landscape is much richer, which is why I do definitely suggest that you like actually look through
ACL
conference proceedings and stuff and find papers that are not amplified as much. So I definitely highly recommend doing this in addition to, Google Scholar or social media or other things like that you might be following.
Okay.
Cool. I'd also like to mention a thing about the ups and downs of preemptive surveys. So surveying extensively before doing research has a bunch of good sides. So it prevents you from duplicating work. So somebody else might have done a very similar thing. It also increases your toolbox of methods. So, if it's a problem that a lot of people have worked on before, then, it helps give you ideas of methods that you could be using. However, in a way, it also kind of constrains your thinking. So if you once you have built up a very extensive survey of ways to do things, you tend to move away from there, when in fact, if you just thought of ways to solve problems without looking at everything, you might come up with something over here. It might actually be a good idea, right? And so there's this really nice essay. It was actually shared with me by Chris Manning from Stanford. It's called "How to Build an Economics Model in Your Spare Time." It's from a Nobel Prize winner in economics, but he's talking about how when he tries to come up with new and important ideas, he doesn't look at economics journals. He looks at the newspaper and tries to, look at problems that people are talking about in the newspaper.
Take inspiration from real life and not academia.
And think about whether there's an economic solution to them. And so if we think about the analog of how we can do this in natural language processing, maybe you don't necessarily right away want to do a really extensive survey. First, you might just think about what's bothering you.
I mean, sometimes you have an idea and you just want to see if people have worked on it, or if they have, how can you look at it in a different light? So that should help with the constraining your thinking. But if you're coming with a blank slate and you want to get ideas from doing a survey, yeah, I can see how that could do that.
When you're using ChatGPT, what is really frustrating to you about how it gives responses? Or what are the things you wish it were possible to do through natural language processing, but are not possible to do?
Yeah, that's my look. That's where I'm coming from. Some things are not available for my language, and I want them to be. That's my stance.
And then you can start from there. You can look at, what companies are doing in their tech demos, because the tech demos might be nice, but they almost never work as well as the tech demo.
Side eye to Gemini, the Gemini tech demo. That was horrendous. I mean, they made it look like it works live, but it doesn't.
Makes them seem like they work. So that could be another place to get ideas. Or you can look at papers in a related field, like machine learning. Let's say you're a machine learning oriented person and you really love math and stuff like that. It's well, there's this good mathematical tool that I think could be applicable to
cross, working in a cross field between fields is super helpful, because you have ideas that could be new. And also just Dropbox famously faked theirs and made a video about their product before they made the product. That's basically like those ads that those game ads that the game doesn't exist. They just want to see if there's interest. Wow. Yeah.
a certain problem in NLP or something like that. So you could do that too.
The
final one, comes with all the caveats of doing top-down research, of course. So, you need to make sure that that really is the correct tool for whatever you want to solve. But definitely, this is something to think about. However, for assignment 3, you need to do a survey. So
you need to do it. There's no choice. I learned about the strawberry stuff yesterday, OpenAI strawberry stuff. They're good at creating hype. That I will give them that. I don't know if it's the like fandom that they have, or it's them leaving crumbs.
I'm forcing you to do a survey for assignment 3. So if you're going to do something like this, you can do it before assignment 3 and start thinking about what you want to be doing. So it's something.
I think I'll stop here. I loved this. Wow.
Any questions or discussion about that part? This is hard. I'm happy to discuss either.
I mean, the hard thing is the implementation, the understanding. He's doing a great job at it. This is not as hard as the other stuff he was talking about.
Now or in office hours or anything like that.
Aww, I want that.
Okay.
Okay. Cool. Wow. You know, it says analyze data. There's no part that says I shouldn't. I mean, I don't mean to criticize, but where's the part where I get my data? Test it, but where's my data? Okay, I really love this lecture, and this baby is going. So, this is going to take a while. So yeah, we can come back tomorrow and finish this, and then by then we'll have the answer to this. See if our loss goes down or our stuff goes up, whatever it is, or if we overfit. I really like this lecture. Wow. And we're not even halfway through it. Did you like today's stream? Because I did. I think I did. I mean, I most of the time I like the idea of the things that I'm doing, and then when I get to doing the things, I chicken out. So I'm glad I have not chickened out of this learning stuff. Yeah, I think today is like stream number 35 or something. So pat on the shoulders or something. Yeah. So thank you for sticking around and for the chat. I do really enjoy that. And if you have any suggestions, criticism, or anything, do let me know. I'm available on comment box, Twitter or Discord or wherever. Yeah. I don't think I have any reason not to stream tomorrow, so inshallah I'll see you tomorrow. But if I do, then hey, that's life. Is there anything interesting I want to share? I watched the movie Wonderland very recently. I have one. You're smart. Thank you. I even if you, I guess, I mean, it's like something that I have worn as an identity badge for so long that I feel uncomfortable having it be a part of my identity. And when I fail, thinking that I'm failing, you know, that way. It's like being the top student in your class. I mean, I'm not saying I was the top student always. I wasn't, not in high school. Yeah, or even in college. But like, I will say I was the top student during my master's. So hey, there's that. Yeah, it does not help with the perfectionism. So yeah. I do wear it like a badge, which is not healthy. Okay. Yes, like it's a way that I think of myself, and when I don't fulfill that image of myself, then it crumbles my world or something. Is that the right way to say it? My world crumbles down like that. So yeah, but thank you. I will accept the compliment. Yeah. So I watched the movie Wonderland. It's a Korean movie, and it's about virtual representation, virtual I can't. you know, the Mr. Beast and the I don't know, other characters that exist as an AI character you can talk to that way. Hey, thank you, thank you. Um, so those AI characters, but like your relatives that are deceased. That's the idea. I think that was a pretty interesting way of exploring that idea. So that's a recommendation if you have time to watch a movie. And also, there are way too many cool actors in that movie, so it's a waste not to watch it. One of them is the guy from the train station scene of Squid Game, the one that does Taxi. Is that the game? Is that Replica? What Replica? Is that it? Is that the thing? Yeah. I think I've seen YouTube videos about this, but is this about deceased people? Because it feels like anyway, that feels like taking advantage of people that, yeah, okay. Anyway, yeah. But as a movie, it's a cool exploration of idea. And also, I'm in the recommendation spirit. I watched yeah, I know. I watched a video about it. I think about it being NSFW mobile try. Yeah. I just googled their name, and many of the questions was like, why is it not no longer intimate? It's like, okay, probably that's probably what I watched as well. Sarah Z's video. I watched her stuff. Yeah. Yeah, in the same recommendation spirit, Super Eye Patch Wolf, I think that's his name, made a video about social anxiety horror. That was so cool. So I recommend you watch it. It's a long video, but it's worth it. It's about content built around, I think it's social anxiety. That's what it is. So yeah. Okay. Thank you for today. I think I'm gonna actually end it now because we've been live for cool, an hour and 38 minutes, not counting the 5 minutes of issues with the other stream. All right. That's all. I wish you a lovely Saturday. It's the weekend. I wish you a lovely weekend and lovely rest of the week. I'm gonna end the stream starting with 5. Let me know if there's anything. Otherwise, thank you. Congratulations. Proud of you. It took you around like 40 minutes or something, right? Honestly, thumbs up. Perfect time. Yeah. Because I thought I was gonna end the stream 20 minutes ago, but I didn't. So I am glad you had the chance to report back. Okay. So that's it for today. Do let me know if there's anything else. Otherwise, I will end the stream in 5, 4, 3, 2, 1. Goodbye and thank you.